Hi there guys, today we're working on solving square root equations. So before we talk about solving square root equations, which are things that don't look like this, that have a square root in them, we really need to think about what are inverse functions. And inverse functions are just functions that undo each other, so just they undo each other. So we've been used to seeing some inverse functions, we just haven't called them maybe inverse functions yet. We've got addition and subtraction, they undo each other. We've got like multiplication and division, they undo each other, so they're inverse functions and these guys are inverse functions. So the inverse function of a square root is to square something, so let's just call it square root of x and x squared. These guys are inverse functions, which says that they undo each other. Oops, there shouldn't be any overlap up here, please excuse me for that. So when we're looking to undo a square root, because we obviously don't like the square root, we can square something on both sides to get rid of it. So the first thing I'm going to do, because this square root is isolated, is I'm going to square what's on both sides. So 9 squared is easy, we're going to get 81. The square root of b plus 3 quantity squared means multiply it by itself. So we're going to get the square root of b plus 3 times the square root of b plus 3, which says that when we multiply our radicals, remember outside by outside, inside by inside, we're going to get b plus 3 squared on the inside. And of course we could say b times b gives us b squared, b times 3, and distribute all the way out, but let's just leave it like this right now. So the square root of something squared is going to cancel out. The square root of 3 squared, well 3 squared is 9, the square root of that is 3. So the squared and the square root and cancel out, we'll have b plus 3 gives us 81, which now this is an Algebra 1 level problem, so we're going to subtract 3 on both sides. We need b equals, of course, 78. Woohoo! Alright, this is not the last step. The last step, you need to check these solutions, because a lot of times you'll have what's called an extraneous solution. So you're going to check for extraneous solutions. Extraneous solutions. So what we're going to do is just, I'm going to put a little check mark over here and say I'm checking b equals 78. So I go back to my original equation. Wherever there is a b, I'm going to put 78 instead. So square root instead of a b, 78 plus 3 equals 9. Okay, so order operations, we're going to simplify. Remember that square root signs act like groupings, so work your way from the inside out. 78 plus 3 is 81. So the square root of 9, or 81, is both positive and negative 9. We're dealing with just the principal root right now, which I've mentioned this, but let's talk about it more. The principal root is when you take the square roots, but you only want the absolute value answer. So I'm just looking for just the principal root. I realize that the square root of 81 is both positive 9 and negative 9, but when we're looking at these problems, we're just looking at the principal root here. Okay, problem second. So this is where we have the square root by itself equals a number. We now have the square root by itself equals a variable. So if we were to, we got to square this thing. That's how we get rid of the square root. So let's square this thing. I don't know what I was going with that. Let's square both sides. So I can write this out again, but I know that eventually I'm going to get 6x quantity squared on the inside of the square root is going to equal x squared. X times squared is x squared. And this is going to skip this step here. We're going to get down to just the square root of 6x quantity squared. And again, the squared and the square root will cancel each other out. We're going to get 6x equals x squared, which this should look very familiar from our fall semester and quadratics. So we're going to get everything on one side of the equal sign, where we have the highest degree term positive. So I'm going to subtract 6x on both sides. These are not like terms, so I'm not going to subtract them from each other. I'm going to get x squared minus 6x. So then we have to do a couple things. We could use this, so we could solve this, so we could solve with factoring is the first method to try. And the second method is going to be the quadratic formula. Remember the negative b, all that stuff? And you can remember, always use the quadratic formula. The number 2s you can always do, but you may sometimes have to, it may not be able to factor, but this one is far easier. So I'm going to try factoring first. So I know I can factor a greatest common factor out of both these terms of x. So I'm going to have x equals, so x squared divided by x is x, negative 6x divided by x is negative 6, and then you
okay, we get two things that multiply to give us 0. So either one of those things has to be 0 or the other one has to be 0. So I'm going to add 6 on both sides. So 6 equals x and 0 equals x. And remember, when you check your answer, you have to check this both ways. So let's check it with 0 first. So the square root of 6 times 0 equals 2. Okay, let's do the second one. So x equals 6. Square root of 6 times 6 equals 6, which is 36. 6 times 6 is 36. The square root of 36 does equal 6. Woohoo! Alright, no extraneous solutions on this one. 2 solutions for this problem, 1 solution for the last problem. So let's go on to example 3. So example 3 is similar to both 5.3 and a 5.4 now. So the thing that's up with example 3 is that we have this rational exponent. So we're just remember back from 5.3, convert this. It's in rational exponent form. I don't know how to solve an equation with rational exponents at the moment. So I'm just going to convert this to square root. We've got the first power, which says it's going to kind of go away. Our index is 2, which is the standard. We'll have 20 minus r, and then this looks very, very, very similar to example number 2. So we're going to square both sides to get rid of the squared and the square root. So we're going to eventually get 20 minus r squared. Square root of all that equals r squared. Squared and the square root will cancel because they are inverse functions. So we get 20 minus r equals r squared, which we're then going to get everything on the highest degree side, which is the right side. So this is positive. I want my highest degree term to be positive. So I'm going to add r to both sides, and I'm going to subtract 20 on both sides, all in one fell swoop. So those are going to cancel. Those are going to cancel. We get 0. R squared, none of these are like terms, plus r minus 20. And again, you can use a quadratic formula if you want to, where a is 1, b is 1, and c is negative 20. I am gonna factor. So I know that I'm going to have to set my parentheses up in 2 pairs. The only thing that can be r squared is r times r. I need to multiply to get negative 20, but add to be positive 1. So that's positive 5 and negative 4. Positive 5 times negative 4 is negative 20, and positive 5 minus 4 is positive 1. So plus 5 and minus 4. We use the zero product property again. 2 things multiplying, 2 binomials that are multiplying this time to equals r minus 4. Solve these just like algebra 1 level problems at this point. Negative 5 equals r, and we're going to have positive 4 equals r, and now we're still going to have to check both of these. So we'll go back to the original problem, and I'm actually going to go to my translated form first. I know this is my original problem, but I don't want to translate every single time. So I'm just going to go into, I'm going to use the square root of 20 minus r equals r. And that's just my first step after I translated it. So then let's check for r equals negative 5. So we're going to have 20 minus negative 5 equals negative 5. So 20 minus negative 5 is 20 plus 5, which is 25. The square root of 25, again, we're looking at the principal root, is 5, which unfortunately does not equal negative 5. So this is called an extraneous solution. It does not work. Let's check the other one. R equals 4. So we've got the square root of 20 minus 4 equals 4. 20 minus 4 is 16. Copy everything else down. Square root of 16 is 4. We're looking at the principal square root, which says yes, r equals 4. So we came up with an extraneous solution, which means that r equals negative 5 is not actually a solution, even though the algebra worked out on it. Instead, our only solution to this problem is r equals positive 4. Okay, guys, come get your worksheet. Let's get started on the practice. Let's try to finish up 5.4.